Hello, and welcome to our talk on hardening Spinnaker pipelines. I am Jacques Thomas. I am a security engineer at Bright Machines, and this work was done while I was a security engineer at Snap. My co-presenters are Jacob, who's a software engineer at Armory and did a lot of the work on Policy Engine, and Tim, who's the CTO at Styra, who are the makers of OPA, which is the system that is used to perform the access control decisions that are then enforced by Policy Engine to then do pipeline access controls in Spinnaker with Policy Engine. But before we get into the talk, let's discuss what we will cover. So I will put some motivation on why we did this work. I will present some pipeline security best practices and building blocks that I found along the way with some help. And then I will pass it to Jacob, who will cover runtime pipeline access controls. And then he will pass it to Tim, who will cover how to work with OPA. Now, as a disclaimer, this is a community update or progress report. It's still work in progress. It's not fully fleshed out and final. The reason we wanted to do this presentation is to put our work out there and get some feedback and hopefully some enthusiasm from the community. Now, before going further, I'd like to thank Perry, who was my co-conspirator when I was at Snap, Beth at Armory, who convinced us that this work was worth a talk, Alice, who also at Armory, who helped me with the pipeline security building block, and of course, the whole Policy Engine team at Armory and the team at Styra. This would not exist without their work. So the motivation. The motivation is that we want only high integrity and high value artifacts to go to high integrity clusters. So as an example, consider the code that serves ads. We want ads to the code for ads to strictly go to ad servers. And we want the ad servers to strictly run the ads code. So we don't want the ads code to go to the interns cluster or the interns code to go to the ad server. And additionally, we want only like high quality ads code to actually be deployed. So we want to make sure there's peer reviews and so on. So there's two parts to the security of those pipelines. There's the strong isolation between pipelines, and then there's the integrity checks on pipelines. And for the integrity checks, there's the static ones. Does the pipeline have the right structure? And there's the runtime, which is the right data flowing through the pipeline? Is the history correct? The static part is something that existed last year with Policy Engine, but Policy Engine, Jacob will cover that, but it was deeply integrated into the Armory version of Spinnaker. And the runtime was just not doable. And so now the runtime is doable, and that will be presented later. Now, for pipeline isolation and hardening at Snap and with the advice from Alice, what we started doing is make sure that for all the high value pipelines where we get high value code and high value clusters, there's a single identity throughout the pipeline that is a system identity and not a user identity that is permissioned. So then we use our tool to lease access so that only while they're working on a pipeline do users actually have the permission to manually trigger a pipeline. Otherwise, it is all automated triggers where the pipeline runs under the pipeline identity. In addition to that, there's another building block that can be useful for places where maybe not all the deployment is fully automated yet. So you do a manual approval, and to make sure that it cannot get essentially like bypassed, you make it so that a specific role is needed to approve a manual approval within the pipeline, which then essentially switches, because you can have the manual approval capture the identity of the person doing the manual approval. So then it switches the identity of the pipeline to the identity that then has permissions to push to the clusters. So these are the basic building blocks that we found along the way. But then you're still left with questions, as I alluded to, about runtime access control, like can we do dynamic separation of duty? can we verify that the trigger of a pipeline is properly signed? Or can we verify that the container is built based on code that was reviewed? All these, typically the answer before this work was, yeah, you can. You just build a custom stage for the pipeline. With this work, we're getting towards more generic mechanisms where you can configure policies that then get the work done without a custom stage. And with that, I will hand it to Jacob to present the runtime access controls.
Hi, I'm Jacob Kobernik, and I'm going to talk about runtime pipeline access controls. Specifically here, we're talking about Policy Engine. Where Policy Engine was last year at Spinnaker Summit is it was simply a static pipeline inspection tool that ran at save time. So at save time, it would, like Jacques was talking about, it actually sent the pipeline configuration to Open Policy Agent and did policy evaluation, and then either allowed or disallowed the save. It was baked into Armory's extension of Spinnaker. So those two things actually provided some limitations. Once again, you're not getting dynamic values. So this is just static values, static configuration. And also, you would have to upgrade Spinnaker anytime you wanted new updates to Policy Engine. We wanted to take this to the next level. And as Jacques already explained, how important doing runtime evaluation is, making sure that the data flowing through the pipeline is what you anticipate it to be. We wanted to move in that direction. So we looked at where to move this to, how we could actually take advantage of that. And we realized what we needed to do is we needed to move Policy Engine to a plugin, and also move an integration into ORCA to be able to now examine the pipeline and stage execution and look at that context for policy evaluation. So inside ORCA, essentially what's going on at a high level is we're just taking all of the context from a pipeline execution at every single stage, at every task of every stage. We're packaging that up and sending that as JSON to Open Policy Agent. The reason why we integrated into ORCA was because we wanted to get as much data as we could, as much dynamic data. We wanted to examine every piece of data that was flowing through that pipe when it was being evaluated. And ORCA gave us the fine-grained control to not only see all the dynamic data, but also act on it if we needed to. You might be asking how much data. Well, this is just a little example here. This is from my development pipeline. But notice on the left-hand side, yes, that's 700 lines of context in JSON form being sent to Open Policy Agent. Now, in production systems, staging systems, you might even get 5 times that amount. Just depends on what you have running, but configuration can definitely grow. And with that, what OPA can see grows as well. So a couple things that are inside this JSON payload that's being sent to Open Policy Agent. I'm going to point out a few things here, but like I said, there's a lot. Authentication, notification configuration, your stage configuration. We'll dive into that in a second. Triggers, and I'll show a demo on triggers. But this is stuff that you might want to actually evaluate, stuff that's flowing through the pipeline. You might want to go ahead and take a look at and write policy against. So looking at stage configuration, we've got a couple different things. We've got output artifacts, manifest details. So this is the deploy manifest stage. So we're seeing some configuration that's specific to this stage. Ports inside the manifest, the type. So these are things that you could all essentially write policy against if you wanted to, and much, much more. Let me show a demo really quick. This is a demo blocking manual pipeline execution. So just imagine a scenario where you want to allow users to actually view pipelines, but you don't want them to execute any pipelines. You want pipelines to only be executed maybe by like a webhook, for instance, or a pub sub. So jumping into my Spinnaker, this is my dev Spinnaker. Notice here that once we run it, so we hit start manual execution, and we get a failure, which is actually the exact same failure you already see on screen. clicking into that failure, take a look at this. Failed on startup, policy infringement, trigger cannot be manual. Okay, so this is what it looks like when Policy Engine runs. Now this is open source Spinnaker. It's running a plugin, Policy Engine plugin. That's the only thing that's happening here is just a plugin is running, and you're seeing a UI that's very familiar. Nothing special about that. But what's happening when this policy gets evaluated and you get that response, that denial response, and the pipeline doesn't start? Let's look a little bit at what that looks like. So on the right-hand side here, this is the policy that's living in Open Policy Agent. And on the left-hand side, this is actually the JSON input that's being sent to Open Policy Agent. I've trimmed a few things because 700 lines doesn't fit on a slide real well, but I'm sure you can bear with me and imagine what the entire contents might look like. So here we have, if you're looking on the right, you can see that we're actually looking for the pipeline on the input, and inside the pipeline we're looking for the trigger object, and we're looking for the type of that trigger object. So what's happening here is we're evaluating input pipeline trigger.type to see if it's manual. And if it's manual, then we'll go ahead and set the deny message, trigger cannot be manual, and return that, have Open Policy Agent return that to Policy Engine plugin running in Spinnaker. So the input object here is actually on the left. And notice now if you map it down, the JSON, pipeline, trigger, and type, the type does equal manual. And so in this particular case, which is the failure case you saw in the previous slide, what's happening is OPA is returning a deny message, and that's bubbling up to the user. At the same time, the execution of the pipeline, it doesn't happen actually. In this case, it doesn't even start. So failed on startup. Okay, now maybe you're asking, what do I do when this happens? So we're gonna actually fix this, quote unquote. We're going to conform to policy in this case. And notice it says to use a webhook. So let's go ahead and configure a webhook real quick. We jump into the configuration of the pipeline and we add a trigger. And the type of trigger we're going to add is webhook. We'll just use demo as source. And then notice that the trigger is now enabled on our pipeline. Okay, cool. We're good to go. Let's go ahead and trigger that pipeline. Now, you don't actually need an artifact in this case. We didn't put any artifact constraints on that trigger, but I'm going to show you what this looks like in the input to OPA in a second. So we'll just add something in here that looks like something that you'd actually get when you're having a GitHub trigger or some other artifact to trigger a pipeline execution. So we'll send this, and notice we get a 200 response, and our event processed was true with an event ID, so we can track it in the system. We flip back over to the pipeline and check it out, running just fine. Everything looks good. And also notice here, you can see it was triggered by a webhook. So once again, let's go ahead and inspect what the input was to OPA that OPA saw under the hood, because the same policy that denied this execution, this pipeline before, was run, but this time it passed. Now, yes, the pipeline configuration did change. It got a webhook, but the triggering was actually the data flowing through that pipe. So same policy here on the right. Looking on the left, notice this time the type is actually webhook. There's a couple other things going on here on the left too, so I'm going to actually show you that. I mentioned before about the artifacts, so just sort of looking inside here, there's artifact data as well. Okay, so I showed you a demo. It's a bit of a contrived example, I know, but this is sort of just scratches the surface of what's possible. There's a few ideas about what's next and what you could possibly build with this. Some ideas, something you could build is artifact signature verification, verifying that an artifact that's being deployed through a pipeline actually meets a signature to know it's from a verified source. Another one is possibly verifying that the deploying user is not the same one who approved the code that's being deployed. So that gets into the separation of responsibilities. And something else I just want to add here, and as you get into OPA, some of the cool stuff about even just using Policy Engine to surface this rich data, this dynamic data, is policy discovery. You surface all this pipeline execution context, and suddenly you're able to see a lot about what's happening and what's happening at every stage of your pipeline as it executes. And so in a permissive mode, so you don't have policies written against this stuff. It's just data that's being observed and is not changing any of your process for your deployments. However, it's something that can be actionable. So you can go ahead and take action on that. I've seen it before where someone wants to write a policy. They actually just look through the logs to figure out what OPA is getting. And then they're able to use that as building blocks to be able to write policy. And that data that's coming from Spinnaker is very rich. There's a lot of things that can be done with it. This sort of building on that idea, this is, I think, a big takeaway I want you to get, is that Policy Engine is really, it's a deployment debugger being operated by Open Policy Agent. An Open Policy Agent is programmed by the Rego policies that you write. So just think about how every step of the execution in Spinnaker is now being intercepted by Policy Engine, and Policy Engine is now sending the content of that. It's hitting pause on the execution. It's sending the context of what's going on to Open Policy Agent, and an Open Policy Agent, based on the programming of policies, either decides, yes, let this continue, or no, we need to stop this. We need to fail this execution right now. It gets a little bit more into Open Policy Agent, which is an incredible topic, and I'll leave that for Tim to tell you about.
Great. So Jacob and Jacques did a great job of sort of articulating why having rich policy controls within Spinnaker are so valuable, and then also showing sort of how that works once it's in place. What I'm going to do is talk a little bit about the Open Policy Agent project, what it is, why it's valuable, and especially how it can be used with Spinnaker. So the key thing here about the Open Policy Agent, or OPA as we like to call it, is that it is a cloud-native computing foundation project. It is completely open source and has been since day one. The goal of the project is to make policy a first-class citizen. The idea there being that what OPA does is it defines a policy file format, a way of expressing authorization or other kinds of policies in a text file. It also provides a piece of software, a policy engine, that can accept those policy files as input. And then when asked for policy decisions, it can go ahead and make those decisions. And then finally, OPA provides a collection of tools that allow us to help with the whole policy lifecycle for testing policies, writing them, and building them, and so on and so forth. So you've already seen an example from Jacob about what those policy files look like, especially with Spinnaker. So what I'm going to focus on more so is the policy engine OPA and some of the tools that it provides. Now, when OPA and Spinnaker are integrated, this is kind of the picture that I think you should have in your heads. The idea being that anytime Spinnaker decides that it needs a policy decision for any reason, it cobbles together a bunch of JSON data or YAML, as you saw in Jacob's demo, and it hands that JSON over to OPA. OPA then takes whatever policies it's been loaded with, uses those policies to make a decision. That policy decision is then handed back to Spinnaker. The important thing about this is that Spinnaker is responsible for enforcing those decisions. It is OPA's responsibility to make those decisions. The other thing that I want to call out on this slide is this data in JSON in the lower right-hand side. So one of the key things about OPA when you're writing policies is that OPA does not have built within it knowledge about Spinnaker pipelines. It hasn't been, it doesn't have that information built within it, so that OPA can be applied to really any kind of policy query that you hand it. And we see that that's pretty valuable and useful. We saw that in the demo. The other side of that is that the OPA was designed to be able to work with sort of arbitrary JSON. And so certainly one kind of arbitrary JSON that comes in is from the policy query. We saw that in Jacob's demo. But the other kind of JSON that you can utilize is shown there in the lower right-hand corner. We like to say that OPA allows you to write contextually aware policies, policies that are aware of and respond to the world in which they're being evaluated. So maybe that, and so what OPA allows you to do is sort of inject arbitrary external data into it, and there are a couple of ways of doing that, so that when you're writing policies, you can actually, condition those policies on, whoever on the list of people who are on call, or maybe the author or the commit that was the last one in this repository that the pipeline was triggered on. So that kind of external data is possible to inject into OPA as long as it's JSON. And now, as a policy author, well, I'm writing policy over arbitrary JSON that comes in as my policy query. But now I also have this arbitrary JSON that I can use sort of as backup or contextual data when I go ahead and make my decision. So that's pretty exciting, because what that opens the door for is all these rich kinds of policy examples that we talked about earlier. The other side of this is that once you've got OPA integrated into Spinnaker, then there's this policy development kind of question that's left, which is how do you author those policies? How do you test them? How do you debug them? How do you make sure that they're operating correctly? And so the way I like to think about it is that what OPA enables is an entire life cycle for policy, just like we have an entire life cycle for software. And really, those two life cycles pretty much coincide. So there's probably too much text here, but if you focus sort of in the middle there, what you see is all the standard stages for life cycle that you would see from a software perspective. You've got a requirements gathering phase. You've got an author policy. You've then got a CI phase where you might want to test the policy, build artifacts. There's a deployment phase where you take those policies and you deploy them to all the OPAs. OPA can hot patch. Those can be hot patched, and so it can be loaded with new policies automatically or dynamically. There's also monitoring. How do you know those policies are doing what they should? How do you know that the OPAs are healthy? And then there's logging, which is, every time OPA makes a decision, it'd be great to have a log of that for a bunch of different reasons. So those same standard sort of life cycle phases that we see for software, you can apply them with OPA's tooling to policy as well. Now, OPA does provide tools that help with each and every one of these stages. So when it comes to authoring policy, there's support for IDEs like VS Code and IntelliJ. When it comes to CI, there are build tools, like compilers. There's a unit test framework. I'll talk more about that in a little bit. There's a profiler, a benchmarker. And when it comes to deployment, there are a number of ways to get policy and that external data into OPA. The one I'll call out there is a bundle API that allows you to configure OPA to periodically pull down new policies and data from a centralized service. And then there's also monitoring, which is OPA has a dedicated status API that allows you to get the status of OPA, as well as Prometheus metrics if you want those. And then it's got a dedicated logging API. So this one's pretty powerful. It's not logging sort of text files, rather it's logging the input that OPA receives on every decision, the decision that it actually makes, in what I like to call a high fidelity JSON log. So that log allows you to manipulate that with software, that log with software afterwards for debugging or for audit or for search or whatever. What we're going to do is spend a couple minutes on testing, because this is really important, especially if you imagine that you've got Spinnaker deployed, it's connected to OPA, and now it's running in production. So all your policies are working, all your pipelines are doing what you think is correct. But now imagine that you want to go ahead and add a new change to your policy. How do you know that that change is going to be safe, that it's not going to break a bunch of pipelines that are already operating in production? And so that's where testing really comes into play. And so one way to do testing is with OPA's unit test framework. There on the left-hand side, what you see is the same policy that Jacob showed you a little bit ago that denies, that rejects sort of manual triggers. On the right-hand side are some tests, and these are unit tests. So these are just basically more rules in the policy language that OPA provides. And what you'll see here is that really there's a positive test, there's a negative test. I, as a policy author, decided that I wanted each of those kinds of tests. And then what you'll also kind of see here, without going into detail, is that what you're effectively doing is you're defining the input that you want to sort of simulate or mock out being handed to that policy on the left-hand side, and that's what that in variable is. And then what you're doing is you're evaluating the deny rules and asking, well, if you mock out the input keyword with this variable in defined just above, then is it the case that the number of deny messages you get is equal to 1? Or is it the case that the number of deny messages equal to 0? And so here you see the two different kinds of tests. So pretty standard unit testing concepts, I would say. So unit testing is incredibly powerful. Another thing that you can do is you can sort of combine a couple of these tools. So OPA does have a sort of a standard way of evaluating policy against an input, as you might imagine. But that if you combine that with that decision logging API, what you can do is sort of keep a record of all of those past decisions that OPA's been making. And then when an author tries to create or release a new policy, what you can do is sort of back test those old decisions using your new policy and sort of analyze how many of your old decisions would have changed had you put your new policy in place. So, if it's a 1% change, historically speaking, then maybe that's pretty safe. If instead it's a 90% change, that's probably not so safe. So for that kind of application, you will need to do a little bit of assembly behind the scenes and combine these different things yourself. But nevertheless, it's another very powerful way of getting a sense as to how impactful your policy changes are before you deploy them to production. The last thought that I have here is that we've talked about OPA as really a good way of adding rich policy support to Spinnaker, but OPA was designed to solve the policy problem all on its own. It's designed to make policy a first-class citizen, and the nice thing about that then is that what that allows you to do is provide a unified solution to policy across many different cloud-native pieces of software. So on the slide, this is one I always like to show folks because it gives you a sense as to some of the different use cases that people are using OPA for in production at scale today. And so here we're talking about Spinnaker on the upper left-hand side, but another very popular use case is using OPA for Kubernetes admission control. Again, you need rich policy support there. That would be like, Capital One and Intuit are good end user, have given good end user talks about that. Using OPA for microservice authorization is another very popular one. That would be like a Netflix, Yelp, Atlassian have given good talks there. Using OPA with Kafka, I'd call out, Pinterest talk has a good one there. Terraform is another popular use case. And then eventually people always use OPA, seem to start using OPA for Linux or even Docker. So at the end of the day, the goal there of OPA is to provide that unified solution to policy across that cloud native ecosystem, give you that context awareness when it comes to policy.
Well, thank you for listening to our talk. And we hope you learned the following, that for hardening pipelines, there's some standard building blocks and best practices that can give you already some solid isolation between pipelines. That Policy Engine is now a plugin, and that it is now able to capture all the ORCA runtime data. And with the integration with OPA, that makes it an amazing tool to actually debug your system when you put the policies in warning mode, because you get essentially a view into all the data that is flowing through the system that wasn't that easy to have before. Styra does have more offering there. We just don't want this to be an infomercial, but you should talk to them if you're curious. And then sticking to the open source part, OPA has a very continuous integration approach to policy. Like you can do simulation, you can add non-regression tests to your system. So that's pretty powerful, because that lets you, if you really worry, like Perry, for instance, worry about the uptime of your Spinnaker system, and you want to deploy access controls, you can essentially have intake tests as part of the way the policy as code gets pushed to your Spinnaker system to make sure that you will not regress based on previous postmortem, for instance, like make sure the postmortem stick. So yeah, this is what we were excited to present. We hope you liked it, and thank you. We're all on the Spinnaker Slack. Feel free to reach out. Hopefully this spiked your interest. Thank you again.